So if we've got that epilimnion at the very top, remember that's that warm layer, and now we hit the fall, that epilimnion is going to get cooler. Oop, back up. Put my pen back. Okay, so the epilimnion is going to get cooler, and remember what happens to cooler water? Okay, as it approaches 4 degrees Celsius, it's going to sink. And again, we get that mixing of nutrients from the top sinking down and nutrients from the bottom coming back up. Again, this fall mixing is really important to redistributing those nutrients before we set in with that winter stratification again. So just to kind of do an overview of those really important mixing periods during the spring and the fall mixing, part of what helps to mix it, besides the sinking of the layers and the changes in densities, is that that lake is always exposed to the wind. And during the spring and fall, that wind has a bigger effect on the mixing than in the summer and the winter. Because the lake is so stratified in the summer and the winter, the mixing doesn't really get very deep from the wind. So the wind may, mix the top layer, but nothing else. In the spring and the fall, because that wind is helping and it's easier for the wind to mix, you get a lot more mixing in those time periods. This is also determined by what's called the fetch of the lake. And the fetch of the lake is basically how much of the lake is exposed to wind, if you want to think about it that way. So the surface area of the lake and how much of that lake gets a direct effective wind, and for how much of the wind that actually blows across the lake is it going directly across the lake. So you can think about it this way: the fetch is the amount of wind that's getting into the lake to help mix it. Also, the size of the lake is going to affect fall and spring mixing. So not just the wind that the lake is getting, but how big is that lake in general? How deep is that lake? Not just the surface area that gets mixed by the wind, but also the depth of it. So I want to talk about that a little bit more, how that size of the lake can affect the mixing. So the types of lakes, as I said, again, based on their fetch and their size, that we have divided our categories into by mixing regime, it's called. So how often they get mixed. There are 4 categories. Most lakes in Minnesota are what's called the dimictic lakes. Okay, that's this first one here, dimictic. And di, hopefully you remember, the prefix means 2. So those lakes get mixed twice a year, typically in the fall and the spring. Okay, what we were just talking about. So that fall and spring mixing helping to return the nutrients throughout the whole lake itself. Lake Minnetonka, if you're familiar with Lake Minnetonka near the cities, that is a dimictic lake. As I said, most lakes in Minnesota are. There are some other types, though. Monomictic, mono meaning one, only get mixed 1 year. So they are mixed through the winter and the spring. So there's no stratification during the winter, in other words. And Lake Superior is one of those lakes. You can imagine why that is. Lake Superior is such a huge lake that it doesn't completely freeze over. So they don't have, in Lake Superior, it doesn't have that stratification in the winter. Third type is called polymictic. Again, pay attention to your prefixes. Poly means many. So a lake that mixes many times throughout the year. Mille Lacs Lake is a great example of this, being such a large lake and a deep lake. It mixes quite often. And then the last type, which is probably the rarest in Minnesota, is called a miromictic lake. And this lake never gets totally mixed because the bottom is stagnant. In other words, for whatever reason, the mixing that does occur in that lake doesn't include the bottom. So the bottom always stays the same. The nutrients that are sitting at the bottom never get brought up. They just always stay down there. And there is a lake in northern Minnesota in Itasca County, so near the headwaters of the Mississippi River, called Deming Lake. That is a miromictic lake. But again, these are pretty unusual lakes in Minnesota.